All right, I have a mathematical file here set up to show you how some of the variables affect, um, how some of the pieces affect the graphs here. So I'm plotting the a divided by 1 plus e cosine of t minus h. Now the minus h is essentially it's going to just be, let me give you something here. So this graph over here, if I change h, um, the graph on the right here is just the r versus theta, like it was in rectangular coordinates. So the graph on the left is the actual polar graph. So the thing is, if I change h, all it does is shifts the graph on the right, but a shift in the theta direction is a rotation in polar coordinates. So you can see the graph on the left there rotating as I change h. So anyway, I'm just shifting in the theta direction. Now, e is the eccentricity. E is changing from something with an eccentricity close to 0, which looks a lot like a circle. And you can see that over here, the radius is essentially constant. And I can change that by changing a. A is just a scale factor here. It'll just scale everything up to be a little bigger. This looks very much like a circle. Hard to tell that it's not actually a circle. My eccentricity, I'm only allowing it to get down to 0.1. Actually, I could get it down to 0 here if I just do this. Change that. Redo this. And it reset the size of everything and made stuff smaller so we can't see it as well, but let's just scoot this back up again here so we can see things in about the right size. There we go. Yeah, so now I get all the way down to that's actually a circle centered at the origin. But if I change the eccentricity, you see that bump forming over on the graph over here on the right, and the closest approach here is still at theta equals 0. That's the closest to the origin you get there. But at just 3 point something here, 3.14 is where we're up at the highest point on this graph, which means at an angle of pi is when we're out the farthest distance over there. And so we go from just over 2, it looks like, up to about maybe 8.5 for a highest point there. And this is between just over 2 to just over 8.5. When the eccentricity gets bigger, there's a spot where we go from being an ellipse to, notice right here, this is trying to draw on a couple of asymptotes. So there's a spot that just slightly south of that here. Oops, that's A. Sorry, I'm changing A. I want to change the eccentricity. There's this spot where it switches from having no intercepts to 2 intercepts. So now we're looking at a parabola right there. Okay. As that eccentricity gets bigger, then we get those 2 intercepts, and you can see the backside coming in there. Right? There's this little loop down here, which was the other half of that hyperbola. Now, you can't really see it here because it's off of this graph, the amount that I'm showing you anyway. But once the eccentricity is big enough, it pulls it in. So yeah, at any time, any one of these, just rotate it by changing h, right? The graph on the right is just a shift in the theta direction. But a shift in the theta direction when you're dealing with polar coordinates is a rotation. So you can get any one of these conic sections with a focus at the origin, oriented at any angle, really very simply by just a over 1 plus e cosine of t minus h. Now the fact that it's cosine and not sine is somewhat irrelevant because of the shiftingness, right? You can turn a cosine curve into a sine curve just by shifting it. So the fact that this is a cosine curve, we could make it, let's see if I can do this, we could make it a sine curve, and we're still going to have similar things. It's going to reset the sizes of things, but you still will be able to see a sine. But now it's a little different because oh, I changed one of them to sine. I didn't change the other one to sine. Let's do sine on both of these. There we go. This will look a little better. Yeah, because now what's happening? Well, the asymptote is forming out here at 3 pi over 2, which is where, so that's extending out this way. But that cosine curve has been shifted over by pi over 2, so where it used to be having its, getting the bump in the middle, now it's the bump is shifted over. If we made that a negative sine curve, then the shift would be in the other direction. And it would look like an upside down sine curve. Let's try that. Where's the bump form? Yeah, the bump's forming there at pi over 2. So it's the same kind of picture. And we can make it look just like the cosine picture by shifting it back, by the right amount, and it looks just like before. So whether this is a sine or a cosine there in the denominator, it doesn't make any difference. Whether it's a plus sign or a minus sign, it doesn't make any difference. The only difference that makes is what is the orientation with no shift, right? When h is 0, right, there's using a negative sine curve. Here's using a positive sine curve. And let's see what happens, right? Shift is, it's that way now. Cosine curves will be centered around the x-axis. Right? We do this with, whoops, we do this with a cosine curve. And you can see it shifted on the x. Anyway, there's a bit of animation to let you see how some of those pieces affect the graph.